So 4 bits in binary, what will that be when I convert it to decimal? With 2 to the power 4, right? So you can go till 0 to 15. If I'm using an integer number, 8 bits will go up to? 2 to the power 8. Which is? 2 to the power 8 is? 2 but now so kids, the 2 powers, the beauty of computer science is that we do computation, but our own computation is very limited to 2 to the power numbers. Remember 2 to the power almost till 12. That is kind of quite really. So we have now got a problem. You said it's 8 bit. It only goes to 2 to 56. Even if I define the 8 bits as your characteristic and matrix, I can't go very high numbers. It's essentially not 8 or 4. So think again. It could have been 8 bits if you were slightly older. We had 8-bit machines. How many bit machines are most of your computers? 64 bits down. So floating point number follows a 64 bit. They follow the IEEE 754 standard. But this gives you 15-bit accuracy or 15-digit accuracy in your numbers. So quite often we have to deal with numbers. Start again. Can you hear me now? Well, you guys can always hear me, hopefully. So if you need better or different, I'm going to just recommend some packages. It's not always the best package, but there will be other, but this might be a good package to start with. So a decent package is decimal package. So have all of you got your Anaconda running? Let me see if mine has started. Oh, mine doesn't like starting today. Yes. Now I know why it was not starting, because my computer was stuck in network login. So if you can start your Qt console on your Anaconda, and let's play with. If you're having difficulty, shout at me. I would like you to be running rather than me talking. Okay? And let's explore the pluses and minuses of the decimal package. So it allows us to do arbitrary precision object for floating point numbers. And what would be arbitrary? So actually, you know what? Let me give you a code. So if you can look at a number, so what I'm trying to do here is I'm trying to say divide 22 by 7, because that's a number which we often see in our school days. What's 22 by 7? Is it pi? Is it pi, or is it an approximation to pi? So how do you remember pi? Till how many decimal digits do you know how to remember pi? 3.1, 4, 5, 6. 4 digits? Has no one told you the mnemonic, may I have a larger cup of coffee after attending a complex lecture on quantum mechanics? Okay. My son is remembering this right now. He's 10-year-old. So he thinks the more number of pi I can remember. So may I have a larger cup of coffee? Yeah. So may is 3, pi is 1, half is 4, and so on and so forth. Okay? So not going into pi because MATLAB is a good way to remember pi is the decimal. Let's try to deal with this decimal package C. If you can, so what I have done here is I have created a new number D. So the decimal get context tells you how many bits are being used currently, what kind of object it is, and then I've done the division of this by 22 by 7 to see what's the number which comes here. And the next line, I have changed the number of precision here to 10-bit precision, and then I've got 50-bit precision. I've done the same maths again. So let's see if you can do it to a different precision and be able to work. So all you should be, if you have got your Qt console running, all you should do is import decimal and you should be fine after that. So at some point, I will leave my chair and come to your machines to check if it's working. If not, do give me a shout. So when you just do decimal of get context, what's divided as your pattern give it to you. Distribution of pattern idea. Sir? Distribution of pattern idea. Let's check.
You can just check once. By version CMD. Anaconda तो नहीं है, but Python might be installed. I'm not sure.
I don't think there is much here.
Jupyter, can check it. Jupyter. No.
No.
So you can use the Colab, I guess. Google Colab.
Online जाना पड़ेगा ना.
जी sir.
Okay, let's see if these guys can run it.
Okay.
So can you somebody give me the reply of the decimal.get context? The first line. I'll walk and see if you have got your get context run. Hang on. Spider. You have 50 consoles, right? Last one, first column, generally. Alright. Okay, and last one is spider. Anything, any interpreter you want. I'm not going to bind you to any particular interpreter as long as you can get it running. So you two guys, should we swap you so that you sit next to it? Okay? So we have one to sit here. Oh, I can figure with you. Let's carry you for the masters. Right? Should we join one of these guys with you? So one person move forward, and actually both of you move forward and sit together. I installed her there. ठीक है, जुपिटर या कुछ और है तो भी you can run it on that. Right, so let's give it a time till you guys get things installed. Somebody should be running it on your. अगर आप spider run कर रहे हैं तो spider पर भी आपको मिलना चाहिए. So can you give me the output of what does get context tell you?
Context procedure is equals to 28, rounding is equals to round half even, e means equals to minus 999,
Good.
e max equals to 999.
Good. So let's limit to the precision. So how many bit precision it is giving us?
28.
20. Actually, it's not 28 bit. It's giving you 28 decimal places. Right? And now change the precision. So do we only have one machine there with both the girls? Not giving him both the girls, right? You don't understand that thing. Acha. Should I shift you somewhere else? You're okay to? Okay, fair enough. So now let's see if we can change the precision to 4. I've done it for 10. See if you can do it for 4. And then can somebody tell me what's the rounding of error when we do it 4-bit versus 28, 4 decimal places versus 28 decimal places? Guys, the quicker the reply you give to me, the quicker we'll proceed.
Same evening and
Sorry?
evening and impact are same.
Good. But we are able to change the precision, right? So if you are following me, so here I have created 3 numbers, D, E and F. And you can see the rounding off here goes from 2857 to 3. What would be interesting to see, just stop the rounding before 8 and see where it rounds up to. 9 or does it round up to 8? So do till 4 decimal places. Did you at least ask his permission to join him? या फिर he asked them if they want you or not. Or you did the major sin. At least he removed the bag of a gentleman. You removed the bag of a lady. That's never to be touched. हाँ, बिना पूछे आप उनका बैग एक जगह से दूसरी जगह, वर्ल्ड वॉर शुरू होते हैं भाई लेडीज बैग पर, संभल कर रहने को. Good. So hopefully all of you, is anyone still not getting the decimal package running?
So that D equals to decimal 1, we are getting error.
Decimal 1?
Decimal 22.
You're getting an error in dividing 2 numbers. What's the error?
Model object is
भैया बुढ़े हो गए हम लोग. Okay, which version is your thing? What, your object is not callable? Is everyone having the same error? Is it not imported?
decimal is important.
But so this is the problem when it happens when you have many machines, because I don't know what libraries are already there on your systems. What you guys, any luck? They're getting in. Yeah, that's what we should get. They are getting in module object is not imported error. No, you are getting right? Or were you also getting this error? No, that's what I expect to see. What are you? You are using an Colab, right? Should we shift everyone to Colab? Okay, guys, they can make it work on Colab. Should we shift to Colab? Because I'm not going to debug everyone's machine. That will be real pain. Let's go to Colab and see if you can make it work there. If not, stick with me. We're not going to play much with decimal package. It was just an advisory on what can be done if you want to change the precision. Okay? So, we had these different type of data types there. The important data type for financial analysis is the string data type, because a lot of our data is often in forms of some form of text. I should use its volume. Better. Yes. Now, to all those who have already done their Python basics, what's the difference between tuple and list? Oh, the technical classic answer, immutable versus, what does that mean? Good. And what's dict? Okay. Good. So I don't need to go through it. Everyone is clear with these things? Okay. Now, in strings, particularly when handling large CSV files, and those who are having strange data formats, one advisory which I give to my student is to use the regular expressions package, and that works very nicely. Okay. Good. Now, these are going to be your real good friends, the list and dictor, because we're going to deal with large number of data series. So we can put everything as an array. How many of you have already done data structures? One or two, okay. So you know how a dictionary will work and what kind of data type it is that. Good. Now, essentially in time series analysis or a lot of financial analysis, we are dealing with arrays of numbers. The first order thing would be to use something like list to create these arrays. Unfortunately, list was not designed for creating arrays. It's much broader than that. It can do many other things than just pure simple arrays. And hence it limits its usability, or its not usability but ease to use. The other option is you can use the array class, but an even cooler class will be numpy.ndArray. Okay, but it gives us a lot of built-in methods, and particularly when you are going to do multi-dimensional arrays, it becomes quite handy to use it. So let's try. So latecomers, we have started. They're showing me a phone for. But I meant to say that we have started working on computers. So if you have got a computer, start running it. If not, join one of the people with a machine. Okay? So what I would like to do now is to see what happens when we multiply a list with a number versus an ND array with a number. Okay? So hopefully you can run something very simple like import numpy as something, create an array, whatever numbers you put an array there, and then also create a list of same type of numbers and multiply them with 2, or multiply or do a square. So 47, 48, that should do. And then just do line number 55, 2 times A. Can also create another list. Let's call it M or L and do 2 times that. And let's see what's the difference. Can somebody tell me the difference once you have got it running?
So 2 times A, all the elements get multiplied by 2, and A power 8. All the elements get the power.
So this is you're talking about ND arrays, right? A is an ND array. What I'm asking you is now create a simple list with the same numbers and do 2 times that.
All the numbers get copied.
Get copied again. And that's the first difference we'll see between a list and an empty array structure. So one person has got it. Has anyone else got it? Is the question clear? Those who are still struggling, raise your hand and I will come to you and fix your. Let's do a walk around. क्या हो रहा है आपकी मशीन में? चल रहा है कुछ? और आप लोग क्या कर रहे हैं? So one of the reasons I like my Qt console is it has got a white background. I have become tired of dealing with a black background. You know, as you get older, आपकी आंखें खराब होने लगती हैं. खासकर people like us who have spent our life looking at a screen. So can somebody else tell me what's going on? आपके यहाँ क्या हो रहा है? So that's an ND array, right? Now create a list, normal list. आप लोगों ने कहा था कि लिस्ट के बारे में आपको पता है, तो I'm sure you guys can run it. Have you done it? Does it repeat itself in list? Good. What about you guys? NumPy not defined. Yes, so it should be np.nd array, right? What about you? But yeah, this is a health and safety hazard. इस दिन मुझे गिराओगे आप लोग यहाँ पर. We just started. Okay, fine. So create an array. Create a smaller array, right? And if nothing work, इस पर नहीं काम कर रहा होगा, then we have got something to worry about. So if everything works according to plan, 2 times a for ND array leads to scalar multiplication, as if you take a vector and you just multiply that each element of that vector with the same number. Okay? If you take a list and multiply it with 2 times, it essentially copies the list twice. Agreed? Don't worry, bhaiya, मैं move करता रहूँगा. Happy? Let's give another minute for our newcomers to catch up. Okay, the other issue between these two is the speed. And this is vital for us. We are लोग छोटे छोटे numbers deal कर रहे हैं, right? And most of you are using the CPU of your computer. So let's now compare the speed between list and ND arrays to how fast or slow it is. Okay? So what I would like to do is to create a list of random numbers and just add those numbers. So I think this is how you will go about creating a list of random numbers here. And the first line should tell us what's the time the CPU has taken to run it. Now, it's not the most well-written code. We are just basically using a for loop to create a sequence of numbers. So now we will start seeing differences between your machines. So each one of you will give me a different time. So there are 2 time equations which we are looking at. The second one is for adding all of these numbers, and the first one is just for creating it. So give me how much time it takes. Will it be beneficial if I share the slides so that you can cut and copy and paste the code? You do have tab extension in most of them, right? So you can type the first few words and that will extend. Okay, when we're in the early days, let's do it last way. That way you learn not to do mistakes, but later on we will share the code. And if it's taking too long, just create a 500 by 500 matrix rather than a 1000 by 1000 matrix. That's not one line, by the way. There are 3 lines here. Right? So I would have hoped that. So what's your CPU time for this? What mistake have I done? I'm getting a unexpected character after line count. So what's the mistake? If you get this working, we should also be looking at creating the same matrix using NumPy and taking how much time that takes. And here's the code for doing that. You got the time, okay? So what was error in my previous code?
So that backslash. And the first line, time mat, it won't be there. Perfect time won't be there. Only mat is supposed to.
Why not? How do you find the time then?
Sir, only that backslash.
Only the backslash is a problem. Right. So now compare this time to the time for an ND array. So can you give me your time on your machine?
Sir, 453 milliseconds.
453 zero nanoseconds. Are you using online version of a Python? You're creating a MATLAB of 5 by 5 array, right? यार कंप्यूटर की इतनी भी मजाक मत उड़ाओ 5 by 5 array तो कोई भी play कर लेता है. Let's do a 10,000 by 10,000 array. That's what we are doing. We're creating a large matrix and we want to see what happens when we deal with large matrix. Okay? So guys, the error here is that this backslash, I think that had come when I was copying from my Jupyter code. Right? So remove this backslash and just create this time and tell me how much CPU time it took you. 1.53 second. So everyone has a faster computer than I have. What's the size of the array which you are creating? 10,000. Okay. And what's the time you needed to add these numbers? Just give me first decimal place. 3.9 nanosecond. Second. So to create an array, which is 10,000 by 10,000, you took 3.5 seconds. Right? That seems like a decent number. I'm jealous with this girl's computer. I need to check how fast the machine is. Oh, you are running it on. Oh, no, you are running it locally, right?
So total time is 271 seconds.
1.53 second, right? Not nanosecond. Nanosecond was worrying me. So guys, this is interesting. To create a 1,000 by 1,000 array or 10,000, we are taking 1.5 seconds, which is slow. Okay, so very soon we'll be pushing your computers beyond its comfort zone. Let me just check if everyone else has got it running. What about you guys?
Remote slash still showing.
कहाँ पर? Let me see. Random.cows 01. For J range of I and for ये क्या है? कौन सा वेरिएबल है यहाँ? Let's run it. What have you defined here? What about you? Got it working? Give me the time. Still it's long. What about you guys? What's the time which you have got? Uh-huh.
2 point something second, but now I will give 10,000, so it will take 1 minute and 21 seconds.
Good. What about you guys? 40 seconds. Good. And back there? What, 1.9 second or did you say picosecond? Millisecond. Millisecond. I'm impressed whenever a machine works faster than expected, right? You're creating 1,000 matrix array. I've asked you to create 10,000. That's cheating. So you see, Janta, we have got this complexity, right? मेरा machine आप लोग से fast होना चाहिए. ज़्यादा पैसे दिए थे. Good. So we are all dealing in terms of seconds, if not more, right? And compile time is even longer now. Okay? So note down these numbers. Okay? So this is the number which is used to create a 10,000 by 10,000 matrix and add all the numbers. The second one should give you the size of the matrix, which is fine. Okay? Now let's do the same operation using NumPy. And let's see is there a time difference between these two. So to give you a comparative, so मेरे machine में the list process took 34 seconds, where NumPy took 3 seconds of CPU time. So NumPy takes 1 second less. Only 1 second less. I got 10 times benefit on my machine. Are you looking at addition of numbers or you're looking just at creation?
This is just creation.
And what about addition of these two numbers? .3 seconds. Is it longer? NumPy is taking longer than normal list for you. So which is taking longer, NumPy or normal list? By how many times? Times. Now that sounds more impressive. Let me go and check this girl and see if how she has managed to make it just run in 1 second. So good. So that's 1.53 second. Now you have 141 millisecond. Right? Agreed? So you get a 10 times runtime advantage. हुआ 10 बार 10 टाइम फास्टर हुआ ना 10 टाइम फास्टर है राइट सो NumPy is giving me 10 times faster computation all of you at least 10 times so 8 to 10 times faster आपको मिलेगा मिला no, nothing comes for free does it अगर NumPy इतना फास्ट कर तो लिस्ट वाले भी अपने आप को फास्ट करते what are we paying for this speed Nothing comes. There's no free lunch in the market, is there? Good. We will see what are we paying very shortly. The next thing which I would like to tell you about. So this is just introducing to the NumPy package. There are 10,000 different things which you can do with ND arrays, and we can spend the whole day just talking about ND arrays, which we don't have time from. The other thing which we do quite often do in financial analysis or any business analysis to deal with time series data, right? We have got data at each time interval. And sometimes it's not just one sequence of data, it's multiple column data. So this is where Pandas time frame and series objects become very, very handy for us. So a data frame allows us to have a tabular data organized in columns. And series is kind of the one-dimensional approximation of data frame. So series allows us to have a one-dimensional data object with an index. Right? So there's a numeric index with there. So let's again play with this. Let's create a data frame object. So it is very much like as if you're working with an Excel data or any SQL database. I have just created a very, very small, I've taken the data again from your Celsius, a very small database. So import pandas as something and then create a two-dimensional database. Okay. And then we will play with what happens with some of the simple structures which a data frame enables us. So it enables very quick searching so you can find a particular index, you can find multiple indices. So we're dealing with a small matrix because then we can learn how to do simple analysis on that before we start dealing with more complex number. Can somebody close the door, please? I will do it. So here in what I have created is a 4-row element wherein the indices are A, B, C, D and the values are 10, 20, 30 and 40. ठीक है? And then you can do simple things like list all the indexes, list all the columns, look for location of say any particular value of index and so on and so forth. ठीक है? आप सबों ने have you created a data frame object? Now this is vital because I'm going to play on this data frame. Okay, so I will wait till everyone has got the first part. So I need to hear a yes from all of you. Should give given you a buzzer. जब आपका काम हो जाए तो press a buzzer. Students don't like talking. क्लासरूम छोड़ के सभी जगह आवाज निकलती है, right? So I'm following yours helps, but considering कि मैं ये काम रात को 1 बजे कर रहा था, there is high probability I would have done a mistake while copying things. So after giving my lecture yesterday, I went and slept at 4 p.m. in the evening. और फिर 9 बजे मेरी नींद टूटी और फिर मैं सो ही नहीं पाया. So I started checking the code again. So our next task will be something very, very simple. That will be to square the numbers and then see if we can do a better way of squaring. How much time does squaring these numbers takes? So we have these numbers 10, 20, 30, 40. I would like to square them. Something as simple as that. So there are 2 ways I could do it. I could just do a normal squaring, or I could, go with a step. We can also add those numbers. Now, can you tell? So give me the differences. Same. The last two, means sum is just adding the numbers, right? No, I want to know the time. Result to same ही होगा. I don't think computer can do 10 square mistake, but I want to know the time it takes to do that. So to give you my operation, so just df squared immediately takes 440 microsecond on my machine. Whereas if I do df dot apply, it takes me 1.35 millisecond. So time find करने के लिए क्या करेंगे? You'll put percentage time before that operator. Zero nanosecond. बड़ा फास्ट मशीन है भाई आपका. This makes me jealous. Anything which takes zero time, you have made a perpetual motion machine, right? यहाँ छोड़ो, NVIDIA को बीट करने का ये करेंगे. Good. And do standard squaring. Both is taking 0 nanosecond. Brilliant. Well done. Okay. Sorry? Huh. 4 microsecond. Okay. So it's a छोटा series, right? Four numbers को multiply कर रहे हैं. Should we make it a 10,000 sequence? नहीं, अभी नहीं करते हैं, because there's something more important for us to deal with. So all of you have squared the numbers? Good. Let's go to the next thing. Let's try to increase it now. Okay? Now, this depends. It's possible to increase a data frame in both dimensions. You can add X column, you can add Y column. Now, it depends upon अगर आपके पास पुराना manual है या फिर पुराना version है, you would be able to use df.append. अगर आपके पास नया Panda है, then you need df.concat. Okay? But let's just use the very simple structure. Just put another column, df float. So give it another name and just let's give some more numbers to that. Okay? So we have gone from an index and one column to a data with two columns now. Just कोई random number add कीजिए. It doesn't matter what we are adding right now because we want to deal with the season.
It is taking 3 seconds. And by normal squaring, and by lambda it is 8.
Good. Okay. It seems 4-digit numbers were not very nice, but बड़ा जल्दी computer काम कर लेता था, right? So let's make it a life a bit more interesting and let's deal with a proper data series, right? So either I can import a financial data immediately, and this was one of the worries which I had yesterday. If I give you a data immediately, I have no idea how good or bad your computers are. Okay? So to start with, let's deal with a random number sequence. What we will now do is we'll create a 9x4 column of random numbers. Assume they are some sort of stock prices. Okay? And the beauty of dealing with random numbers is each one of you will have a different number to play with. So let's do this. Let's just create a simple data frame object with a 9x4, and you can take any random seed you want. Okay? So I've started with this random seed of 100. You take any number which you want. Let's create a data frame. And then let's give it a label to each column on top. और अभी कोई टाइमिंग नहीं देखेंगे हम लोग. We just want to create the object because I want to play with the sequence now. then the next bit is all about just, it can give you how to find the sum of a number, how to find the mean, how to find the sum of one column, how to find sum through the rows. So basic simple operations on arrays can be done quickly. जब आप लोग रेडी हो मुझे कहिएगा, and I will move next. Ready? You have got a data frame object and you have added a column to it. Good. One person is ready. Another. Now, if you look at your DF, your data, it looks like a sequence of numbers, right? There should be 9 rows and 4 columns to it. That could as well represent a database which we have read from the financial market. Okay. So the first thing which I might like to do is just find simple statistical measures, which would be easy for me to do. Should I move on? Anybody wants me to keep holding this slide, or you guys are okay? Unless I get a nod from everyone. Second row, first column. Are you guys okay? And third row, guys? Okay? Good. Now, in a time sequence data, we often have some sort of time index. So right now, your index will be 0, 1, 2, 3. So if you look at your index is 0 to 9, right? Let's change that index to some form of a date stamps. Okay. And let's give it a date which ranges from 1 person and has got 9 periods in it. So now if you are with me, you should have got a 9 column, 4 rows, but the index is now a timed index rather than just some numbers. Okay? Okay, what happened? Computer died? Power cable चाहिए? A solution might be if in future for you guys to sit in just one column so that we can access the wall things. So if you have already got till this point, where you have got a time series data, what we would like to do next is to do some maths on it. There's other things which you can do. You can find the average, you can find the log data. But what would be interesting to see if we can plot some of it as to how it behaves. Okay. So come some plots the cumulative addition, so it adds each number, so it should theoretically be linearly going up number. So we should be able to get bar plots as well as a timed plot after doing this exercise. And now we'll go around checking how you guys have got up to it. I'll let you figure out if there's a syntax error. क्या हुआ? कोई syntax error आया क्या? Okay, I'll let you figure that out. So what you guys? Oh yes, that's looking like now financial data, right? Something is happening. You can't plot. Good. It's looking like some financial data. It could as well be performance of a stock, right? Now I know I've started very easily, but you will see very soon we are jumping into. May you have it? Okay. So we have not defined DF, but हम लोग पिछले. So we created DF paid off. Okay, so you should have stopped here itself. Now, if nothing works, stop me then and there. Okay, so that I will come and have a look. That's where it should be random dot standard. It's not random standard, it's random dot standard. Try. See if it runs. ED is not different. Did you import? Okay, you imported. Okay, now let's do the next one. Okay. Let's then plot the numbers, and then I will ask them if we are going very fast or slow. So guys, after we have got nice looking waveform, okay, so oopsie, sorry. So that's the time series person. Show me the bar plots as well. Okay.
I'd like to do that.
Oh, that's... And then we will take a tea break after this. Okay. So have we got the sequency data? And it all of a sudden looks like an actual bank data, right? And we've started with random numbers. The beauty of data engineering is you can show nice graphs without having any actual freaking data behind you. So now you know whenever you try to open a bank account and then they show कि return इतना मिलेगा आपको, how it's easy to create that. We haven't done any financial analysis till now, but क्या हो रहा है भाई लोग यहाँ पर? Okay, you have got everything increasing. बड़ा अच्छा शेयर प्राइस है भाई. ठीक? नहीं आपने different random number लिया. ठीक है. It looks like a financial data. So rather than giving them financial data, I want to create something which looks like one. Okay. DF नहीं define किया. Okay, fine. But you know what to do, I guess. Right, guys. So all of those who have got it, we'll stop and take a break now. Can we? And now you have to tell me because I have been going very slow this morning. Okie dokie. Moving on then. So let's think something else when it comes to financial data. So our DF, data frame object which we have created, DF, looks like a financial data. Okay, we have seen its sequence, we have seen the graph forms which it does. Let's now try to see. So mathematical comparison आप बहुत कर सकते हैं, right? I can find mean, you can put it in ascending order, descending order, ये सब आप कर सकते हैं. Let's try to do some text-based processing. Because financial data में सिर्फ numbers नहीं होते, text भी होता है. And one of the text which often appears is the quarter data. कई बार banks आपको interest quarterly देते हैं, right? Rather than monthly analysis, we do quarterly analysis. So let's add a column to our DF. So we're still dealing with the same object जो हमने शुरू किया था, called quarter column. Okay? And we're giving some randomized quarter data here. Okay. Then what we can do is we can group the data based on its column basis. So some facial features are suggesting they are lost. Now what we are might be interested in कि per quarter में हमको कितना profit हो रहा है. Yeah, what's the minimum sale in a particular quarter? These might be sales figures. So I can now classify the whole data frame with groups and find their mean, max, or do some sort of aggregation there. So I'll come around and like to have the response of the last line. So whenever you have got the last line ready, call me.